Okay, this is another situation of special limit that involves sign. So what we can do here is that we can actually make the sign become a special limit. As you can see, we have sine 3x squared. So 3x squared is the function is carrying. So we can use it to multiply and divide it. If we do that, we are going to have limit as x tends to 0, 3x squared sine 3x squared all over 3x squared. Then at the denominator, we have a common factor, which is x squared. So if I factorize x squared, I'm going to have x plus 1. So if you do this correctly, you'll be able to cancel out x squared. So x squared is gone. What do we have left? So we have limit as x tends to 0, 3 sine 3x squared over 3x squared all over x plus 1. Now we can recall our special limits. Recall that limit as x tends to 0 sine x over x is 1. So with that we can substitute and this becomes 1. X is 0. So that means I'm going to have 3 times 1 over 0 plus 1, leaving us with 3 over 1, which is 2. So that is how we solve problems on special limit that involve sign. I'm going to take one more example. Okay, for this problem, you will discover that we also have sign. That means we can still apply the same rule to the sign while we factorize the numerator. So at the numerator, we have a common factor x. So this will lead us to limit as x tends to 0, x times x plus 1 over sign is carrying just x. So x will multiply and x will divide. So when that happens, x cancels out. Then what is remaining is limit as x tends to 0, x plus 1 over sine x over x. So as we know, this is already a special limit. So all I need to do is to recall. So if I recall, limit as x tends to 0, x tends to 0 plus 1 over 1. No, we're recalling. Recall limit as x tends to 0, sine x over x is 1. So which means if I go ahead and substitute, I'm going to have at the numerator 0 plus 1, and at the denominator 1 due to the special limits. So what is left is 1 over 1, which is 1. Okay? So you can see it gets easier if you just understand the application of the special limit. Okay, this time I decided to take an example that involved tan. I told you tan and sine are treated exactly the same way. So if you look at the question, it's similar to one of the questions we solved with sine. So what we need to do is to make tan a special limit and factorize the denominator. So if we do that, we are going to have limit as x tends to 0, 5x cubed tan 5x cubed over 5x cubed. Then the denominator x cubed is common, remaining x plus 1. So at this point, x cubed can go. You see that? So since x cubed is gone, what is left to be limit as x tends to 0, 5 tan 5x cubed over 5x cubed all over x plus 1. Now recall, the special limit says limit as x tends to 0 tan x over x is 1. So that means anywhere I see tan of a function over that function, it is 1. So this is 1. So I'm left with 5 times 1 all over 0 plus 1. So this will give me 5 over 1, which is 5. So that's how we solve problems like this. Okay, here's another problem. If you look at it from the surface, it looks complicated. But if you follow your basic mathematics rule, you'll be able to reduce it together with the special limit rules. You'll be able to reduce it and get your answer. First of all, looking at it now, you see that w square and w cube have something in common that can cancel out. So that is a good place to start. So w square cancel w cube, you have just w left, right? So let's see what is remaining. And take note, the limit is as w tends to 0, not x. So our focus is w in the question, right? So now I have limit as w tends to 0, 2 cos w plus 4 sine w all over w. Some of us will be able to quickly see that this w can be given to sine w to make it a special limit, since the special limit for sine says sine x over x. So if we have sine w over w, it means we already have a special limit. It's just to recall and substitute. Is that not so? But in case you didn't see it that way, you can still apply the general rule that say whatever sign is carrying, use it to multiply and divide, which means I'm going to have w sine w over w here. But that's a waste of time. Just move this w to this sign, and then you can recall and substitute. So that means I'll just have limits as w tends to 0, 2 cos w plus 4 sine w over w. So this is a special limit. So if I recall, limits as x tends to 0, sine x over x is 1. That means everything can now become 2 cos w tends to 0 plus 4 times 1. So this is what we have now. So this will leave us with 2 cos 0 plus 4 is 4 times 1 remain the same. So that's our answer for this question. Okay, this is another problem still under the special limit. Limit as x tends to 0, x cot x. I didn't give us any special limits that relate to cot x, which means one thing we can do is to break cot to its trigonometry ratio. Cot x is cos x over sine x. Remember, in trigonometry function, tan is sine over cos, while cot is cos over sine. We also see cot as 1 over tan. Since we have tan, we can change it to 1 over tan, or we change it to cos over sine, and we'll still get to where we are going. Any one you use is okay. So if I do that, I'm going to have limits as x tends to 0, x cos x over sine x. Now sine is involved. I need to make that sign a special limit. So this becomes limits as x tends to 0, s cos x over x sine x over x. So making the sine x special limit means I'm introducing x over x to it. So at this point, x can go, leaving us with limits as x tends to 0, cos x over sine x over x. Now all of this is 1. So I just need to recall. So recall that limits as x tends to 0, sine x over x is 1. Also, limits as x tends to 0, cos x is 1. So there are two special limits we are recalling here for the solution. Since it involves cos is also a special limit, and involves sin s over x, which is a special limit. So both of them are 1. That means I have 1 over 1, which is 1 as our answer. This is one more question on special limit. And if you observe, h tends to 0. So our focus is on h. So looking at the question, sine h over 2 can be made a special limit. So if I do that, I'm going to have limits as h tends to 0, sine x plus h over 2. Then this h over 2 will multiply and divide. H over 2 sine h over 2 over h over 2 all over h. I believe you understand what I did to that sign, because it's a special limit. So what can happen here is that h can cancel out. And if h cancel out like that, the constant remaining is 1 over 2. This is already a special limit, as you can see. Is that okay? So bringing out the 1 over 2 here, when h cancel, you leave 1 here. We'll now have limit as h tends to 0, 1 over 2 sine x plus h over 2, then sine h over 2 over h over 2. Now this is a special limit. So all I need to do is to recall. And if you recall, limit as x tends to 0, sine x over x should be 1. So for this reason, this will become 1, and anywhere I see h, I'll put 0. So it's leaving me with 1 over 2 sine x plus 0 over 2 times 1. So this is 1 over 2 sine 0 over 2 is 0, x plus 0 is x, sine x. So that's my answer.